This tutorial is for mile marker 2, practice 1, question 4. In mile marker question 4, we're asked to perform a dilation, and the dilation is going to be centered at a point other than the origin. So let's go through and read the question. Oops, sorry, that was my cat. What are the coordinates of Q prime after Q is dilated by a scale factor of 1/3 centered at 7, -6? So the first thing we've got to do here, and this is really important, we've got to mark this point 7, -6 on the graph. So if you go over to your graph, if we move over to the right, 7 on the x-axis, and then down 6 on the y, we can find this point right here. So this is the center of our dilation. That means that point Q, depending on the scale factor, is either going to move further away from that point or closer to that point. The next thing that I would recommend is that we connect Q to the center by a horizontal and vertical path. So if I go from my center, it doesn't really matter if you go over and then up, or if you start at Q and go over and then down, but we just want to connect Q to the center. Okay, so now let's go back and let's talk about all dilations for a second. Let's talk about their scale factors. So something that we really need to remember here is that if a scale factor is greater than 1, points are going to move away from the center of the dilation. And if a scale factor is between 0 and 1, so in other words, a fraction or decimal value that's between 0 and 1, the points are going to move closer to the center of the dilation. So that's going to shrink the distance between the center of dilation and the point that you're dilating. All right, so if we look, our scale factor is 1/3. So 1/3 we know is between 0 and 1. Okay, so we've got to be really careful now that we understand what happens. This point Q is going to move towards the center of dilation so that its distance from the center is 1/3 of what it currently is. So let's go through, and I'm going to actually kind of try to draw in the diagonal here. It's really tough to do on my iPad. Okay, so essentially Q's distance on that purple path is going to change so that it's now only 1/3 of that distance. So let's look again at just the horizontal and vertical values, and let's go ahead and mark them off into thirds. And you can see that the distance is 3 over and 3 up. So it's really easy to partition 3 into thirds because we just break it up into moving 1 over and 1 up. Because we know 1 is 1/3 of 3. So now here's where we also have to be really careful. A common mistake is that people are going to incorrectly put a point probably right here. This is a common place where people might think that our answer is. But I'm going to tell you that that is if we had a scale factor of 2/3. Because even though we've moved 1/3 in, the scale factor is going to really change the distance from Q to the center. So what we need to do is we need to move another third in, and this purple line I drew isn't perfect. It should go right through this point right here. All right, so this is the point for Q prime. So if we look, the distance from Q prime to the center is now, we're going over 1, up 1, and this distance is like the square root of 2 units. So that distance is 1/3 of the original distance. So our answer for Q prime for its coordinates is going to be 6 is our x coordinate, comma, let's see, -1, 2, 3, 4, 5. So 6, -5.